Hello and welcome. I'm so excited to have you with us today. Today we are going to be talking about robot and structural analysis with robot and Revit. So hopefully that's what you were planning. If you weren't here for structural, you're welcome to leave now so that we don't waste your time. I know that your time is very valuable, and so I do want to thank all of you for joining us. And I'm really excited. I have a great lineup of individuals that are helping us today. My name is Michelle Rasmussen. I'm the AEC Content Manager, so I make sure that you have the learning content you need to get your job done. So after the webinar, if there's anything specific that you need to learn, put that in the survey so that we know what other content to deliver up to you. Like I said, we do have a large group of people here with me today to help us out. Let's see if I can get it to go there. There we go. So this is everyone that we have. So Pavel Pollock actually created the content for this, and I'll show you where you can find that. In our Customer Success Learning Hub, you'll see a full learning path that walks you through the information that we'll be talking about today. So if there's anything that you miss, if you want to go out there and try it yourself, all of these courses have information attached to them. So that has a data set connected to it so that you can actually try it. And it has videos to show you how to do it. So a great way for you to try it without ruining any of your projects in the process of learning. So one thing to keep in mind. All right, with that, so Pavel is actually the one who created that content, and then Stefan is going to be presenting that content to you today live so that you can see how he works through that. And then we have Galom and Aaron and Brian and Tomek all ready to answer your questions. I know that's a lot more than we usually have, but this meetup always seems to have the most amount of questions, and I hate leaving anything unanswered. So I want to thank all of the team here at Autodesk is helping out with this to make sure that your questions get answered. So on that, let's talk about it. Before we jump in though, let's talk about our safe harbor statement. We see this every month, nothing new. If we, by chance, talk about anything forward-looking, if we say, you know, this is in the roadmap or that's in the roadmap to be in the software, it's not a promise that it'll end up there, but we are definitely trying to make sure that we answer all of your needs and get the software working the way you want. So just keep in mind, don't make any purchasing decisions based on any forward-looking statements that we might possibly make. Just one last order of business, and then I'll turn things over to Stefan. Your lines are muted just to reduce the background noise. And that way we can send a recording of this session out to you if you want to rewatch it or share it with your coworkers or boss or whoever that might benefit from this. After the session is over, this is the link to the forum where we can continue the conversation. I've actually put that link in the chat as well. So if you need that, you can go over to the chat panel. If you can't find that chat panel, let me know, and I can put it in the Q&A panel. So it looks like there's still a few people joining, so I would like to give everyone a chance. Put in the Q&A panel, just so you get a practice, where you are coming in from. And it looks like Tony is saying he has no audio. So Tony, I would encourage you to go up to the audio options and start and troubleshoot that. I'll come back and help you through that after I turn it over. So we have Thor coming in from British Columbia, Camille from Denver, Jennifer from Florida, David from Canada. Excellent. I'm going to probably pronounce this wrong, so I apologize up front. Prabhu from India. Jeffrey from France, very nice to have you. I love seeing the global audience with us. Frank from Ontario, Stefan from British Columbia again. I'm sorry, not Stefan, Stephen. Brian from Maine. All right, we have quite a lot of you here with us. It's so wonderful to have you. I don't want to take up any more time. It looks like the numbers have started to level off. So those that are just coming in, hopefully you've got your audio working. If you don't, let me know. We'll try to work through that with you. And with that, let me go ahead and turn over presenter rights to Stefan. So Stefan, you are now a presenter. If you'll share your screen with us.
Yes.
Perfect. I am seeing your slide deck.
Okay.
That looks great.
So what we will do, in fact, it will be two parts, because since you have the data set before, I was thinking that maybe a lot of you have already tried to perform Pavel's lesson, but I will do it live to import the model from Revit to Robot, do the analysis, and then update what has changed in Robot and the result. And after we have a Q&A session, but when I do the round trip, do not hesitate, because my colleague will answer live to your question. Okay? So importing model from Revit to Robot. So at first, and I won't speak a lot to it, you will need to see another lesson that Michel has shown, based on how to set up the analytical model in Revit. Okay, here I will perform the structural analysis with Robot, starting with Revit. So it will be in 4 steps. First, import from Revit to Robot, then do the analysis, export to Revit, and update again. So now I will show you how to import. Okay, so you will have a direct button. Depending on the date in the past, you need to install a plugin. Now it's live for, I think, more than 3 years. And we'll say, send the model to Revit. If you don't have Revit and Robot on the same computer, of course, we will create a SMX file. Okay, this is if you don't have the two software on the same computer. Once you've done that, or I prefer to do it before, I prefer to adjust all the tolerance and preferences in Robot. Okay, so it's about meshing, if you like rigid link, or if you like to mesh again, all this stuff, and about code check, what will you use. Okay, so live demo. So here, so this is my Revit file. So you will have this file in the Pavel lesson. So when you download, you will be able to download and view small video, like I've done. Plus, you will have this file, the Revit and the Robot, and different steps of it to easily follow. So here, at first, you will do a structure link. So here, I could send first, but first, I won't send, because at first, I want to set up my preference in Robot. In fact, when you send, it will take your default preference. So usually what you will do here, so I heard there is a lot of people from US, but can be from Canada, or I heard someone from France. So you will choose globally here your preference. So it will update the working language and pretend language here. And it will set to here the job preference. Okay, but to the default job preference. So for example, here, like you will listen in the Pavel score, I will remote kinetic constraint, because I prefer to mesh and mesh again. And here I will choose user definition of finite element. And I like to have a Delaunay complex mesh without regular. And I could change some other working parameters. Here, the unit, the number of digits I want. Once I've done that, usually I will change, for example, to USA v3. Okay, and this USA v3, I will save it as my default parameter. It means that when I close my Robot, when it will open again, it will be with this default parameter. So now, if I send the file from Revit, so the analytical element, here, it will be with my default parameter set to US. So, as I told you before sending, usually you will look at the analytical element in Revit to see if it's fine. So in plan view, in section, to see if you have only one line, means all is a line, or it's not a line, but there is a good reason. It's all, I would say, connected. And then you will send this. First time, it takes sometimes because you need to align all the database after it's speed up. So here I have the element, and if I look after I have the report, here everything is fine. If there is something which is not so fine, it will be written. So let me come back to robot. So here I have the element. So I can look at it. If I come back in major preference, you know, I'm in USA. So all what I said before, I don't have to set it again. It's already set. Here I have all the code check and the structure analysis check. So here I will perform analysis. So usually what I can set, here I don't need, but I could have set, I would say, it's because it's not saved in the parameter. Here, in the structural model, here you can adjust the tolerance of the structural model. It means that, I will say yes. Here, but in automatic, if two nodes are closer than 1 millimeters, there will be only one, there will be combined, okay? And here, I prefer our customer to use automatic. It means that it's a low process. But you know, sometimes you need result and you can be a user definition. What I would take care of this, it's imagine that you have a column with a big load at the top, and in fact, it's not really connected with the slab or the beam. So it will merge, and it will merge to the gravity center of all the nodes according to, so if it's 2 millimeters, 1 millimeters, it won't change a lot. But if it's more, this load will create a bending moment in the column, which could be, I would say, strange. So I think that we need to use not too much this element. So here I will see. So at first I will create my here I would have created my automatic combination, okay, but I think since I update one time, they are already created. Sorry for that. But I would have done, so I will delete this come from Revit, sorry, 10, 9 to 9 to 9, delete. Okay. So usually I would be like that, but you know, when you do it live, you think you haven't saved, but you have saved, because here, if I look in structural, load cases, load combination, yeah, I think that you cannot see them, but they are in due to the Revit robot link. So here, so what I would have done here, I would have created my automatic combination according to local code. So here, US. Here, I will check all the case, and I will check that the relation between, for example, live load or other exists. I mean, if, for example, all the dead loads are together, or if the live loads are together or not. or here it's fine. I will generate. So, and so my results are out of date because I play with the tolerance. Here. So here I have my combination, and it looks like, you know, here it's envelope, and what I have before was more combination. So at first, when you have this, what it's my first mind, because all the bending moment and sharing come from displacement. So I usually check my displacement. So here I will check first on shell to look. And here, for example, if you have really a strange value, it means that something is not connected the way you want, I would say. So here, maybe I will display the finite element. Yeah, maybe the meshing is a little bit too, it's not thin enough, but let me check. Here, and so I'm not really used to, I think 2, it's fine. Okay. In fact, what I don't like here, I have a column, and I want to have a lot of integration point to have correct results about this, to see the correct binding moment. And usually I have a question when I give lesson in management school, but how do I know it's precise enough? And my answer is, or you could have a very mathematical precise answer, but if after, for a rebar point of view or steel point of view, you don't change the real rebar reinforcement or you don't change the profile, it means you have the good. It means that if, for example, here I select to here have more, not this one, to have more quality, okay? And at the end, it won't change the quantity of rebar I will put for real. It means that previously it was enough. So we are about, I would say, 1, 2, depending on the size of the slab and if it's a global analysis or a local analysis, but you are free to do what you want. Yeah. So what I would say as a general remark, because here I have element is not assigned to any story. If I were the BIM manager or the engineer of this project, for me there is too many levels with not enough distance between these levels. So it's not a problem in robot because it won't work like this, but it could be a problem in maybe other software. But that's why we have this, it's look like this, you know. Okay, so here I have looked at the results on my slab. So for example, if it was this slab was critical for me, usually, you know, I can isolate it to have a scale, especially for the slab, and I will look in a more classic 2D view here, and after I can, you know, tag if I want more here. So characteristic point, extreme point, or I can ask to every finite element center if you want, like this. And if you zoom or unzoom, usually it adapts for you so you can see it. So after I look at the deflection of my slab, maybe here, maybe I would have put a bigger here beam. Let me see here if I display the beam. Yeah, maybe this beam Could be a little bit bigger, but we will see. Okay, and after, because it's about BIM, so here I will clean up what I display. I will move to the diagram map. So if you want, like usually I do, and if you want to have both results, here you can go to result. For example, here I have the diagram, so I can have the deflection on the beam here. And for example, I can display only the beam. So here I will select all the beam and like this, look at only result in my beams. So it seems the deflection, except on this small, yeah, because they are very small profile, are correct. Here you can, from the same, go to parameter and display the result if needed. And same, for example, if you want to have more precision, or you want to move to another unit, you can here or in scientist display if you want here. So it seems like the displacement are good. I used to work with graphic results. Of course, if you need, but it will create a massive result. Here you can go and look at table, okay? But before, usually it's what I look at first, like I explained to you, I look at dead load. But after, what can be good is to look at another load case, for example, live load, but you can look at envelope. So SLS, like this, and here you have all the envelope of the deflection. And after you will be able to directly see if it's nonsense to go to code check or if it's fine, And I could have the same here. I will add the results for map here, deflection. Yeah. Not in this view because of course I will move in this view the shell, the slab and the wall. Yeah. So you can have, both results for maps and for diagrams. Yeah. But after, it's already nice to, because you won't fix everything, you will focus on some element with some value. Okay. So once I've looked at my displacement, usually I look at, and if it's correct, it means that my support are correct and everything is quite fine. I will be interested in my global stress. So for the beam here, I will go on the maximum and slow bending. Yeah. And maybe I won't look at everything. I will go for some here label. And maybe I will isolate here. And after, I will keep only the steel part. This menu Windows, and here I will label. Yeah, I will look if the global stress it's fine according to the steel I have, and one globally it's fine. Usually I will look, for example, here at the deflection in the middle. When it's fine, I will look at the same on concrete, but well, the global stress on concrete from meters or equivalent is not really element. So I look only at deflection usually on slab. And here I would do the same with wood, I would say, if I have wood. So once I look at my result and they are fine, I can go, if needed, you know, on table. For example, I will focus on this on top. So here I will create a selection group. We'll name them top, for example. And so I can isolate them. And if I want to have the result of this in table, I can do in result deflection, for example. I can go to stress as you want. And here I can select again my selection, okay? And I can after do some something you need, for example, on this table. So maybe I will move by case. Here I will select only simple case, and after I could look at global extreme. It means that, you know, I have the load case, or I can go for the envelope, and if needed, because here I am on bars, I can add more points. No, because I am on the deflection here. But if I look at another table, which is not deflection, because of course deflection, you look in the middle of the bar. Here I could, for example, if I look at my load takedown, result, reaction or stress, I could have add some more points here. And after, you know, you can classify the same way. For example, here I will do a load case object with name. And here I will select all the simple case, for example. Yeah, it's a way. Okay. And anytime, sorry for that, I will reopen this table. This table is here, reaction. So, because we are all the way we prefer to display, so I like to have action on the footing and not reaction, which is the classic way. And like I explained to you, I prefer to have load case with objects, and I like to have only simple case. And when I've done this, what I can do, it's I can here and save as table default. Okay, so next time I will open again this, I will have this configuration, and if I want to put this in the report, I can take a screen capture here. Okay, and same for I would say all the graphic stuff here. Anytime you can create screen capture. And what is nice with screen capture, it means that, okay, I take screen capture with this profile. Maybe we haven't checked according to ACI or LRD. So maybe we won't change them. So the stress will change. But here it's not current view, it's update view. It means that when you will launch after the screen, the report, it will be updated. Okay, so now let's move to the your steel design. Okay, so here you see the steel design, because in my preference here it's what I have chosen. Okay, if for example this you want to analyze with another, so here you will see usually by default what we think we as a robot team is used in US, but if you click on more, you will be able to see all the country. Okay, but after it's better to change globally, because if you, for example, want to do according British Standards Eurocode, you will need not only to change here the steel, but you will need to change the load combination here to Eurocode and the wind and snow. Okay, and of course maybe seismic loads. Okay, so let's I will move this. Let's move. So here I will take care of here this beam. So I will create a new. I will start from a beam, and I will call it my beam because you can change default element. My top beam. Okay. So here, here for buckling, I would say we will put some small profile to avoid lateral buckling here. So, no, this, sorry. So here we'll be able to put where you put bracing in every direction, and same for the lateral buckling, because you can have different elements. So imagine here, like in the training, I will put this way the bracing, okay, and I will save this to my top beam, okay. Of course, here you can have and check if you are agree with this verification, okay, and here you can check. As you can see, if it's cantilever, you need to check this, so there is some element. And when you have check all these parameters, so here there is some other coefficient. If sometimes you don't remember what it's about, you just click on help, so it opens in another button, and you will have the robot help. It will explain what it is about. And yeah, that's all. So I will select here, there are already select, so I will apply my top beam to this selection. What I will do now, in fact, I could verify directly this, sorry, this beam. Okay. Copy, paste here. And so here I will select my ULS. So because you have create automatic combination, you don't need to do like that, but I prefer to do it. Here, my dead loads. Okay, live loads. And total. Okay. So you don't need to, but if you don't need to, you need at least to check if the simple case have the definition. No, it's fine. Okay, so when you've done this here, I will remove this. Here you can do the analysis here. And of course, it will do the analysis of each, which is a nonsense because they are all the same. So now I want to update because it works half in constraint and in deflection 10%, I would say. So here I will create a group here, a new group with this list, and I will name it top. So if I just save it, by default, it will do the dimensioning with the W because it's W. But if for example, you want to select other section, from here you can ask for some other section, for example, in plus of W. Maybe I check W or maybe not. Okay. W. Okay. And so I save, and now I will do code group design. So it's the first, and I will do in stress first, analysis, and here it will show me those who works, okay, those who works even better, and those who don't works, you know, but from the last point. But you have to think, okay, here I will choose this, but you have to think that from a design point of view, all the rigidity distributes the deflection, and deflection distributes the bending moment and stress. So sometimes it's a good idea not to choose this one, but to choose this one for example. So let's here, I will change to this. So I will close, so I don't need to save. And now I will do my FEM again. And now I will, because here I won't have look at deflection. Well, before changing, I could have looked at deflection, but here I will check the same with deflection. So here I will verify my number group to stress and deflection. And here I have the ratio, you know. And for example, here you can type HP and auto, and it will show you which one. Because sometimes, you know, sometimes it's obvious, but sometimes maybe you can change your mind. And after you can change. But if you change, usually you will change with a group because you won't change only one. Okay, so that's, and so when it's the final, usually I save because I want to have it in the calculation note. So now I will move to reinforced concrete here. And in reinforced concrete, of course, I could, but it's quite the same. I could have choose reinforced concrete member require non-reinforced. But here, in fact, I have not a lot of concrete. Here I could have used it for this column, for example. Or here it's easy, you can select this column and here go to provide reinforced concrete element. But so here I will focus on shell. So slab reinforcement. So I will do the analysis of, so I fill my screen. So of course you can do all, but I will focus on this slab. So here, if you don't want to see the finite element, you can select this. So after it's easy, and you know the number of the slab. You know, like this. Okay. So I would do the analysis of this slab. So I will isolate, looking in maybe 2D, the best view. So of course, like the deflection, I have not set the ACI parameters. So by default, it will set to default. So here, if you look at the name of the slab, you know, it's 8 for the thickness. Here, you will have it. You will have it by the way here. It's 8 concrete, so it's this one, you see. So it means that it's a constant thickness, 8-inch, okay, and it will use a concrete casting plate. You can see it's here gray. Okay. So, but now we will speak about how do we rebar. So I will choose, for example, here the x-axis as main axis. It means that the rebar, this rebar in dark, will be the main axis. Those who, I would say, work the best. And here, after, I will select the concrete the same as the Revit and Robot file. Here, I will select the grade of steel. The parameter, I will select my deflection and I will put here my allowable deflection. Here I can set the long-term ratio, short-term, and here the rebar I want to rebar this, which will change the cover. And here if I want to have minimum rebar. So I can't change default, so I will call it my reinforced concrete. So I can maybe I already had it. Yeah. Okay, and I will add it to this panel. Here same, I check ULS, so we know what is ULS. I check SLS, so we know what SLS is, and I will do analysis. So I speak, but I choose all the panel to do the analysis. So it's live, we will wait sometimes. So what I can do, it's just when you create the case, in fact, usually it will be in your template here in Revit. Here you have the load case, but depending of what you want, they could have some additional parameters. So between Revit and Robot, we know, so we will put that live loads, it's the good category, but they can have subcategories. And sometimes here, if I just show you, okay, here you need to check if the subcategory are defined. You know, for example, if here I create a live case, no, maybe it's more Eurocode. Yeah, because here in Eurocode we have subcategories. Sorry for that. Here, so here I have do the analysis. So if I have done only this panel, trust me, it would have been much more faster, as you can see. Here, so here you have the rebar needed in one direction. So yeah, here you see in one direction, the other direction. Maybe there is not a lot of live load on this. Yeah. And so from this, after you can save. Here. And when you have do that, so I can have done other elements, I can come back to Revit. So I can do it from anywhere, but it's more logical to be in analytical view. And here in analyze, here I will here come back to update and will update my model plus the result. It means it will create new family. For example, if I have, I have changed a beam to another beam, and this beam may not be present in the family, But between Robot and Revit, since they share the same database, there is automatic family creator. So even if you don't have the BIM will be created. So here I update the model. So during this time, I will summarize what I have done here. So after here, I have performed analysis and design in Robot. So at first, I look at my FEM results, stress, bending moment, constraint. After I do steel design according to US rule. After I do reinforced concrete analysis of the slab. Okay, and then when you have done this, like I'm about to do, I will update this in Revit. So because there is a family creator, even there is not the W family, it will be updated, and it can move from HP to W. It's not a problem, you know. And even if the HP family are not in Revit, and it can be, I would say, a scene section. And now what I do, I will show you is how to display this result, because for slab, when you want to put rebar on top of it, it's nice to have the needed reinforcement, I would say. So you can, if your rebar is can be shorter, or if it's easier to use wire fabric or this kind of things. So and it takes some time. I was thinking about opening and closing a file, but it's 2 minutes, and there is always a tip and tricks. For depending on what if you will have this file, what I'm not a big fan of is slab analytical elements. No, sorry, the footing, because in fact the footing can't adapt to the upper column. So usually here, for example, if maybe you can see for those who are it, the analytical support of footing is a very small anti-key element. So usually I uncheck this and I put here my boundary condition a support, which is by definition at the bottom of the column, because I see some customer file, or even when I do file, and sometimes, I adjust let me just, no, I won't delay but here, usually if I don't use this boundary condition, I activate the support of the slab, because here, if I look in 3D, of course, there is a support because there is a footing here. In fact, sometimes it's not really exactly at the center, and in Robot it creates a node, but not at the bottom of the column, or sometimes not at the good level. So after you can adapt, but so it's not so hard too. So here now I can look at my analytical elements here, and here I can go to my result explorer. So I just updated this, okay, and the time is running. And here I will look at my results, And here I can look at my rebar result, because here I rebar requirement. So of course, because I do the slab analysis on all, I have all the information. And after, well, when you're in Revit, you know, you can select only one slab, analytical beam, analytical floor, and you can, if you want, isolate element to have a better view on this. And you can look at different way of rebarring. Of course, we will have the same as we have in robot. So this is for the slab. So let me just show you. And after, maybe Aaron, you have question I need to answer live.
We have about 8 minutes left to get to some questions. So as soon as we can.
I think we are finished. I just I will look at analysis result. And here, my favorite is deflection. Here, so you can see if it's correct. And after, you can here look at displacement according to Z value. Okay, ready for question? I hope my colleague have worked a lot.
Okay, so Will is asking the question, when using the composite beam add-in, is it possible to update chamber and studs when you pass the model back into Revit?
I think if the customer of this question, it's better that he send us the beam in question in Revit, and we will do the test for him. Because I would have said yes, but maybe if he ask, it's about let me see, not this one. It's this. It's this beam, no? Maybe we can.
Yeah, we can definitely take that one offline if we need to test that. Not a problem.
Yes, because it's better to test with his file, and the best way, I think, or he can test himself looking at what I've done. And if he thinks maybe there could have a workaround or something like that, he can send the Revit robot file to our support, creating a case. And after, people like Guillaume, we look at it and say, we can, and this is a procedure, or we can't, but this is a workaround, and etc. And usually, yeah, if, for example, it's not a standard beam, here you will be able to here put the same name and type of the beam and recreate in robot as a user beam. So you need to export the XF of the section, you know, and after it will match. Okay.
Okay. And I see Francisco Javier Gonzalez. I see your hand is raised. Would you like to ask your question live?
Yeah, I wonder if you don't mind, I have a little question, because when you are working with advanced steel and robot, there's a little issue with the precision of the nodes. When you are importing a model from advanced steel or the other way around, so you see that the nodes or the elements, beams and columns are not in the same point. So the nodes are moved, and you need to correct the model in robot or even in advanced steel. So I wonder if this problem it's also appears on in Revit or not, because it's very common in advanced steel.
In fact, in Revit, if you go from advanced steel to robot, in fact, it will take the center line of the profile, and there are no analytical elements in advanced steel. So it will be exactly the same. It's good in your voice, but sometimes when it's exactly the same, nodes are not connected, you know. So when you go through Revit has analytical element. It means that, for example, let me explain. Here the beam, here it's in this slab. But for real, this beam, it's bottom the slab. You see here?
Yeah, that's what I mean exactly. When you are talking about, for example, a slab in Revit is represented with the thickness as well. And in robot is only a plane without thickness, the representation in the model. So it's a rigid link or something like that. So
Yes.
I wonder how to handle this between Revit and robot.
In fact, if you want element to be connected with beam and shell, you need to adapt the file. That's why we create in Revit this analytical element. But it will be the same if you go to another software, you know, because the slab and the beam are a line or a thin sheet, you know. So if you want it to connect, it needs to adapt, so it won't respect exactly where it is. But if you want that, I have something for you. Here in justification, instead of, no, not here, because here it's a real element, sorry. Here, it's instead of alignment. So here I move manually to the slab. So that's why it's manually adjust. But here you can say projection. And here, if you say center of the element, and same for the other, the analytical element will be exactly where is the, I would say, real element. But after, take care, because you need to create rigid link in robot, because it won't be created. It won't be connected, I would say.
Great. Thank you, Francisco, for being brave to ask that question. So we had a question come in the Q&A panel that was asking, what is the better way to start? Is it better to start in Revit or Robot? And what are best practices to maintain the structural link?
In my opinion, I say that because now I use Revit for more than 10 years. Maybe 10 or 20 years ago, I could start in Robot, but now I prefer to start in Revit, because if you start in Robot, you will draw the analytical line. And so you will draw what is not real. It means that the slab is not there. This is not connected there, it's connected at the top. And so if you create this and after you update this file in Robot, in fact, you will need to adapt every piece, because sometimes, for example, if you have two walls, here I don't have a lot of walls, but usually here, for example, this wall, maybe the thickness is not the same as this one or this one, you know? And so if you start in Robot and after you update and you create the Revit file starting from Robot, it's possible, but you need to adjust the 3D. Of course, the analytical file will be perfect because it comes from Robot, but you will need to adjust a lot. So as conclusion, I would say, if it's a classic building that is it, I would start in Revit and then go to Robot. If it's something that it's really strange, maybe I will start in Robot, you know, because at first, if you feel it won't work, maybe it's better to start in Robot. You know, if it's really a focus on analysis, a very strange shape, without wall, without column, maybe it's better to start in Robot. But if it's a classic building, with a lot of small elements, an alignment, etc. I prefer to start in Revit, because if I start in Robot, after I will need to realign or recreate all these small elements, and I'm sure I will miss some unalignment, you know.
Excellent. Well, time is up. Thank you all for your questions, and thank you for the whole wide team that helped answer those questions. I think this is the first time we've been able to answer all of the questions that came in the background. It looks like we have one that just came in now, so we'll try to get to that. But I want to thank everyone for your time. We know your time is valuable. We hope you really gained a lot from this. And Stefan, thank you so much for the great presentation.
Thank you.
And so again, you know, Guillaume, Tomek, Brian, Aaron, thank you all for helping answer those questions. And we hope to see you back here next month for the next meetup. So thank you, everyone. You have a wonderful, wonderful day.
Thank you. Bye.